Hi guys, it's Ravel here. I'm going to zoom in so you guys can see this a little bit and focus, and then we're going to get started. You have your exam tomorrow. Just a heads up, it's a little bit intense, more intense than kind of what you guys have been used to. So let's spend some time going over these. And if you're here from another teacher, just throw your name in the chat so I know who to text and let them know that you were here. Okay, so first thing we're going to do is we're going to figure out which of these expressions have a factor of x plus 3. And the way we do that is we need to find the greatest common factor or use a difference of squares, or factor using the x method, whatever you guys got to do. That's how we're going to figure out which has a factor of x plus 3. So in A, it's a binomial. We're going to take out the greatest common factor. And in this case, it's 2. Okay, the biggest number that we can take out is 2. We can't take out any variables. We can't do anything else. It's just going to be 2. So when we have that, what are we left with? Well, I took out a 2, which means that in order for me to get to 6, I would have to multiply it by 3. So I'm going to have a 3 there. And then my plus is going to stay the same. I took out a 2, so all I'm left with is x. So in this case, we have 3 plus x plus 3, same thing. So this guy does have a factor of x plus 3. Okay. For B, again, we're going to take out the greatest common factor. And in this case, it does have a 1. We can do that. But we can take out an x. So if I take out an x here, I'm left with x plus 3. And this guy works too. So that guy's all good. Okay. Trinomial. Let's see what we got. For a trinomial, you're going to want to do that x method where we put a times c on top and b on the bottom. So we're going to go a times c is 3. That's 1 times 3 is 3. And then b is negative 4. Okay. Now I'm looking for 2 factors. I need 2 factors that when I multiply them together equal 3. And when I add them together, equal negative 4. Okay, and let's see if I can come up with those. In this case, I'm going to use, let's see, I'm looking for 3. My only factors are 1 and 3. So if I use 1 and 3, that's cool. If I put 1 times 3, that gets me 3. But 1 plus 3 doesn't get me negative 4. So I need to make sure they're both negative, that everything's negative, because negative 1 times negative 3 is positive 3. Negative 1 plus a negative 3 is negative 4. So these both become negative. Now, when you do this, remember you need to drop your a term. A always comes underneath. In this case, it's a 1. There's a 1 right there. So that makes it super easy. And I get x minus 1, x minus 3. So that one right there, no good. I'm looking for, remember, x plus 3. Okay, right here. I have 3 times x squared plus 3. Well, I've already taken out a 3. X squared plus 3 is not the same as x plus 3, so this guy right here is no good. Okay. This one right here, a little tricky. You can factor out a negative 1. So when I factor out a negative 1, I'm left with x plus 3. So this guy right here does work. And remember, when you're factoring, you can always check your work. So you can always check your work by foiling or distributing, by foiling, using the Punnett square, whatever method you guys liked from last week. But in this case, I would distribute. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. And you know that I've basically just rewritten it in another way, but this guy right here is good to go. And then this one right here, again, you have a trinomial. We need to use that method, the x method. So we have a times c. 2 times negative 3 is negative 6. Positive 5. Okay, I'm looking for factors of 6 that when I multiply them together, get me negative 6. When I add them together, get me 5. Okay, so what are my factors of 6? If I can't come up with them off the top of my head, let's write them down. I've got 1 and 6 and 2 and 3. Okay. So if I try 2 and 3, if I do negative 2 times negative 3, that's going to get me a positive 6. So that's not going to work. If I do 2 times 3, that's going to get me a positive 6. So that doesn't work. Let's just try 1 and 6. Okay, and then if I use 1 and 6 here, I know one of them is going to have to be negative. This way, the 5 is positive, so I know my 1 needs to be negative. Okay, so my factors are -1, positive 6. But remember, you're not done. You got to deal with dropping the a term. So let's drop the a term, and in this case, it's 2. Let's reduce. This guy right here is already reduced, so my factor here would be 2x minus 1. Not what I'm looking for. Let's try here. This is 3. X plus 3, 1x plus 3, that's the same. So this guy right here is good to go. So he's okay. So again, in a problem like this on your test, when you have to just pick, it does take a little bit more work because you kind of have to look at all of them and factor them and do the greatest common factor on all of them. So it is a little bit more work. And so you guys need to make sure you're good with that. And that you take your time on tomorrow's test. You're going to get an hour and a half. So you're going to get more time to take your test tomorrow because the test is a little bit harder. Okay, factor completely. Identify the method used. So you have a couple of greatest common factor. Okay, that's one thing you guys can put in. You guys can put in difference of squares. You can put in a trinomial. Trinomial, okay. And then the other one, which I know you guys have talked about already in your classes, is prime. Okay, prime is when you can't factor it. So let's see what we can do first. In a binomial, your choices are pretty much going to be GCF, difference of squares, or prime. You're not going to be able to pick trinomial because there's only 2. Okay? And in this case, I can factor out my greatest common factor. If you're not sure what it is, again, you need to just do the factor tree to break it down. I have 2 x's and 1 here. Okay, I've broken it down as far as I can. What do they each have in common? Well, this one has a 2x and this one has a 2x. So I can factor out a 2x. And what am I left with? I'm left with 2x minus 7. Okay, that is your answer. And you used GCF. Okay, that's your answer. This guy right here, he's a trinomial. Okay, this guy right here is a trinomial because there's 3, 1, 2, 3 terms. And for this one, we're going to use the x method, and we're going to put a -2 there and a positive 1 there. Remember, it's a times c on top, b on the bottom. So I've got 1 times -2 and then 1 there. And I only have easy factors of 2. My factors of 2 are only 2 and 1. So I need a positive 1 and a -2, which means that this guy right here is going to be negative. I'm going to drop my a term. Remember, you always have to drop your a term below on both sides. In this case, my a term is 1. So 1 and 1. And my factors are, remember, the denominator always goes in front of the x. So my factors are x plus 2, x minus 1. If you put the 1 here, that's okay. You have them here. It's not a big deal. Your answers are fine like that. So these are your answers right here. Those are your factors. Each one of these is a factor. Here's a pro tip. If you're not sure you got your factors right, FOIL it out or put it in the Punnett square or do the vertical method, whichever way you guys like, to see if you end up with this. Okay? And so let me check it real quick just to show you guys how this works. Okay? I have x plus 2, x minus 1. Okay? I'm just going to check my work real quick. I'm going to put it in the Punnett square. I love the Punnett square. Okay? I have x and positive 2, x and negative 1. Let's go. We have x times x, x squared. X times 2, 2x. Negative 1 times x, negative 1x. Negative 1 times 2, negative 2. Simplify. X squared plus x, because I've got 2 minus 1, so 1x minus 2. That's what it happens when I FOILed it out. That's what I had when I started. So if you get the same answer when you FOIL it out, you know your factoring is correct. It's worth the time to check your work to make sure you get the question right. Okay. This guy right here, it's a trinomial. Okay. When I have a trinomial, my choices are going to be, if I can take out the greatest common factor, that's cool, but 10, 3, and -1 have nothing in common. I wouldn't have a difference of squares because you're going to have, most of the time, you're going to have two terms with the difference of squares. And I'm going to try factoring it to see if it is prime. So let's do that. Remember, you have A times C on top, that's -10. B on the bottom, -3. And I need two numbers, two factors of 10. 10 is my magical number that when I multiply them together equal -10, sorry. And when I add them together, get me -3. Okay. What are my factors of 10? My factors of 10 are 1 and 10, 2 and 5. So 2 and 5 is looking like a pretty good choice. And let's see what we need. We need a -3. So we're going to make our 5 negative on both of those because 2 times -5 is -10. 2 plus -5 is -3. So we're going to make our factors 2 and -5. But remember, you're not done. Deal with the A term on the bottom, which is 10, and reduce. It's really important that you reduce. You won't see this answer on a multiple choice. You have to reduce it, okay? So that's 1/5. That is -1/2. Bottom number goes in front. 5x plus 1, 2x minus 1. Again, no reason to guess. Let's say you screw it up. You put this number and you go 1x plus 5 and you screw this one up and whatever. If you FOIL it out or put it in the Punnett square to check your work, you'll catch it right away. Do the extra step. Okay. 39 and 13. So we have 39 minus 13p. A lot of people like to just leave this one. You can factor out a 13. 13 does go into 39. It goes in there 3 times, and you get 3 minus p. And again, to check your work, just distribute and make sure you get the same answer. Make sure that when you distribute, you get 39 minus 13p. Okay, and you're good. Check your work. All right. So this one is a GCF. I just factored out the greatest common factor. All right. I've got a binomial and its subtraction. So this one is going to be a difference of squares. And what's great about the difference of squares is that, one, you have to have the difference, which is subtraction. Okay? And you need to make sure that you have perfect squares all around. Okay? Everything you have needs to be a perfect square. And then these I find to be the easiest because they really require the least amount of work. Okay? So 49. 49 is a perfect square. It is 7 and 7. Okay? Because 7 times 7 is 49. X squared is a perfect square. That is x and x. So I have 7 times 7, x times x, 10 times 10. I have 10 and 10. Okay, you've broken them all down. When you have the difference of squares, you always just need to make 1 plus and 1 minus. And it doesn't matter which way you do it because when you multiply it out, you're going to get the same answer no matter what. So there is your difference of squares, breaking it down. Identify that everything has a perfect square. Okay? Your x's, your numbers, everything has a perfect square. Okay? And then the last one, this guy here's a trinomial. I know it's a trinomial because there are 3 terms. And I'm going to try putting it into the x. I have a times c, which is 10 at the top, -5 at the bottom. And I need my factors of 10. I've got 1 and 10, 2 and 5. Well, I'm kind of stuck right now because there are no factors. 2 and 5, I can't get a -5. 1 and 10, I still can't get a -5. So when you cannot factor it, your answer is prime. Okay? Prime is your answer. right? So again, it's going to be heavy factoring. Like on your quiz that you guys took yesterday, you're going to get another one of those problems with big X and all the blank little spaces for you to drag and drop. Make sure you guys get that. Okay? You're going to have problems on your quiz like this where it says factor completely and identify the method used, where you're going to have to say, oh, okay, I used GCF and here's the greatest common factor and I did that. So you're going to have to do it like 2 answers for each one. Okay, so then let's keep going. Page 2. Okay, this one just wants you to identify what the greatest common factor is. It doesn't ask you to factor it. It just says, what's the greatest common factor? Okay, so for this one, I have 5 and 1 are my only factors there. I have X and X. And then for 20, I have 2 and 10, 5 and 2. Okay, what am I left with? I've got, what do they have in common? Well, they both have a 5 in common, and that's all they have in common. So for this one, my GCF is 5. They don't have anything in common. This guy has 2 X's, but this one has none, so I can't do anything with those X's. Okay, let's try this one. All right, I've got 2 X's and a 5 times 1. This one, I've got a 2 times 5 and 3 X's. Okay, let's see what they have in common. They each have in common a 5, and they both have in common 2 X's. So my greatest common factor is 5x squared. Okay. And if you were to factor this, it would look like this, 1 plus 2x. It would be 5x squared. There's your GCF. And then I'd be left with 1 plus 2x. And I can FOIL that or distribute that out and not have any problems. Okay. And the last one, I've got 3 and 5 and 3 x's. And this guy, I've got 5 and 1x. So I've got 5x here and a 5x there. My GCF is just 5x. All right. So easy enough, greatest common factor. Little review. Simplify and identify the degree, leading coefficient, constant, and make sure you're writing it in standard form. Okay, this guy right here, subtraction. So we need to make sure we distribute that negative to everything over there. So I'm going to rewrite this as x squared plus 6x cubed minus 4. This guy stays the same. Minus 5x cubed minus 7x plus 3x squared. And now I'm going to go through and combine like terms. So I got a positive 6x cubed and a negative 5x cubed. That's going to give me 1x cubed. And then I have positive 3x squared and positive 1x squared, which gets me 4x squared. Remember, when you're adding and you're combining like terms, you don't do anything with the exponents except for leave them the same. I've got that, which is negative 7x minus 4. That's the only one that's left. So here I'm at with, I wrote it in standard form. I know it's in standard form because I have the number with the highest variable first. Okay, so the highest exponent here is 3. It goes 3, 2, 1, and then none. So this is in standard form. So good for me. What is the degree? The degree is your highest exponent. So this is a degree of 3. That's my highest exponent. My leading coefficient is the number in front of this. It's the number that's attached to this guy. And in this case, it's a 1. And my constant is the one without a variable. And in this case, my constant is negative 4. If you don't have a constant, then your constant is 0. Okay, let's do this one. This is multiplication. So I know I need to distribute this 4x to each one of these. And when you multiply exponents, remember, you are going to change them. So I have 4x times 3, that's 12x. I have 4x times negative 2x squared. That's negative 8x cubed. Remember, multiply your coefficients, add your exponents. I have 1 here and 2 here. That gives me 3. 4x times 6x cubed, and that gives me 24x to the 4th. Okay, that is not in standard form. I need to rewrite that in standard form. This is my highest exponent, so standard form is going to start with the highest exponent and work our way down. Okay. And in this, my degree is 4. My leading coefficient is 24. And my constant, I don't have any number without a variable, so my constant is 0. So that's standard form, degree, leading coefficient, and constant. Okay, this guy right here. Remember, this does not say square this, square this. This says x minus 6 times x minus 6. And you choose which way you'd like to do this. So Punnett square, FOIL, vertical. This one I am going to FOIL, so I'm going to go first, outside, inside, last. So I get x squared minus 6x minus 6x plus 36. I can combine like terms here. And I get x squared minus 12x plus 36. Okay. That is in standard form. My degree is 2. My highest exponent is 2. My leading coefficient is 1. There's a 1 out there. And my constant is 36. It's the guy without a variable attached. Okay. This one, basic, it's addition. You don't need to change anything, just combine like terms. So in this case, I have positive 3x cubed and negative 2x cubed, which gives me 1x cubed. I have 2x squared and 1x squared, which is going to give me 3x squared. I have that guy by himself, which is positive 7x. And I have this one by itself, which is negative 3. So I've written everything in standard form, again, highest to lowest. My degree is 3, highest exponent. My leading coefficient is 1. In this case, it's the number in front of the term with the highest exponent. And my constant is negative 3. Okay. All right, and the last one, this one's a little challenging. For this one, you have multiplication and subtraction. So you have to deal with this multiplication first. And to deal with the multiplication, remember your choices are Punnett, vertical, FOIL. Okay? Any way you want. Pick one. I will do the, I'll FOIL this one again. If you guys want me to do another method, jump in there. If you guys want me to see, if you guys want me to show you how to do the other ones, I can do that again. So first outside, inside last. I've got 6x squared plus 18x minus 1x minus 3. Combine like terms right here. I've got 6x squared plus 17x minus 3. I'm not done. I still need to deal with this right here. Okay? And this is a subtraction sign, so I need to make sure I distribute that to both. So I'm going to bring it down here. That gives me negative 4x squared plus 3x. And now I can take this and combine like terms again. So I've got positive 6x squared, negative 4x squared. That gets me 2x squared. My x's, I've got 17 and 3 plus 20x. And then I've got my constant right there at the end. My degree is 2. My leading coefficient is 2. My constant is negative 3. and that is in standard form. Okay, so make sure you guys are familiar with all of those again. I heard last week's test, I know from my class, was super strong. I heard in the other classes you guys did great, so this part should just be review. We're just going to kick it up a notch for you. Okay. Ooh, this one's fun, a word problem. Okay. So the length of a rectangular shaped park is 3x plus 5 miles. The width is 2x plus 8 miles. What is the area and perimeter of the park? All right, so I know that looks really ugly, and I think the first thing that we need to do is literally draw the park, okay? And it's a rectangle. Okay. And it tells me that my length is 3x plus 5, and my width is 2x plus 8. Okay, and it wants me to find the area and the perimeter. Well, how do you find the area of a rectangle? The area of a rectangle is just length times width. So this times this. I've got 3x plus 5 times 2x plus 8. You guys know how to do that. You're either foiling or Punnett square. This one I'll put in the Punnett square. Just do that real quick right here. I've got 3x and 5, 2x and 8. Here we go. 6x squared, 10x, 24x, and 40. So I've got 6x squared plus 34x plus 40. Okay, and that's how you leave your answer. Okay, it's this, and then it's in miles, so that would be square miles. Okay, there's your area. Area is length times width. Okay, how do you find perimeter? Okay, perimeter is you just add up the sides, right? It's 2 times the length plus 2 times the width, or I just add up this, 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 and this. Okay, and you know what these are because it's a rectangle. So if this is 3x plus 5, then this is 3x plus 5. If this is 2x plus 8, then this guy is 2x plus 8. And let's just add it all together and see what we have. So I'm going to do this up here at the top. I've got 3x plus 5 plus 3x plus 5 plus 2x plus 8 plus 2x plus 8. Combine like terms, friends. So we've got 3x, 3x, 2x, 2x. Remember, you're not changing your variables, only dealing with the coefficient. 3 plus 3 is 6, 7, 8, 9, 10. I've got 10x. What's left? Positive 5 plus 8 plus 8. So I've got 10 and 16 plus 26. Your perimeter is equal to 10x plus 26. And you would leave your answer like that. Okay, so where something like a word problem, all of a sudden you guys are going to quit. Don't quit on the word problem. Draw yourself a little picture. You guys know how to use a rectangle. You guys know how to find area and perimeter. Don't freak out on a question like that. That's a really easy question. We're asking you to FOIL. It's actually a review question when you think about it, because we're just asking you to FOIL this out, okay, or multiply it out, and then we're asking you to combine like terms. So you guys should absolutely be able to do this. Okay. The absolute value graph is not going away. We're still having issues with it in a lot of the classes, and it's time that you guys just get it all right so that we can stop putting it on the exams, okay? Couple of things. Before we even get into any of this, okay? When you are writing an x-intercept, it is x comma 0, okay? X comma 0. When you're doing the y-intercept, it's 0 comma whatever your y-intercept is. This is tripping up people on every single exam. Okay, please pay attention. Please make sure you guys are not getting tripped up on the basics. You guys know how to do this. Okay, so I want you to write the absolute value equation for the graph below and answer the questions. Okay, well, how do you write the absolute value equation for the graph? Well, we know it's some sort of, you can write f of x or y equals the absolute value of something and something else there. Okay, Usually we have x, and then what are we going to put here? Well, the easiest thing to start with here is your vertex. You guys know to put the vertex here. That's how we find it, okay? And your vertex is at -3, -1. So your vertex is at -3, -1, okay? So when I'm here, what do I put here? Well, I know I need to go the opposite of whatever that is, and then that number by itself. So there you go. Okay. Now, this is fine for the first step. You're going to want to go back and check and make sure this works out okay based on the other questions, but this is a good first step. Okay. Let's look at this. Let's just look at the graph. Do you have a y-intercept at -2, 0? Okay, well, first things first, for it to be a y-intercept, I would have to have the 0 here. So if I'm putting my y-intercept here, my y-intercept is right here. It is at -2, but it's at 0, -2. That's the correct way to write this. This is not correct. That is false. Careful with that. Okay? F of -5 equals 1. Okay, what this says in English is when x equals -5, y equals 1. Okay, when x equals -5, y equals 1. So let me see. When x equals -5, here's where x equals -5. Does y equal 1? Why, yes, it does. Here's -5. Here's 1. It's right there on the line. That guy right there is true. Okay? If you don't like it that way, you can plug it in. Plug it into your equation and see if it comes out equal. All right? Are my roots at -2, 0 and -4, 0? Okay, well, my root is at -4, 0, so this guy's cool, but it's not at -2, 0, it's at +2, 0. So this one right here is false. Again, little things like negatives make a difference, and those are the things that you guys are getting tripped up on, especially on your exam where it's multiple choice. So please, please take your time, look at it, and make sure you guys are going off, the right thing. Okay, is the point 1210, the point 1210 is on the line. Okay, so there's your x and there's your y. Obviously, you're not going to sit here because you're not going to go, oh, 1210, yeah, it kind of looks like it's on the line. No, friends. All right, you're going to plug it into your equation. Okay, so we've got 10 equals the absolute value of 12 plus 3 minus 1. Okay? And 10 is equal to, y-intercept is, oh, hold on. I think I screwed up your equation here. I did screw it up. Your vertex is -1, -3. Hey, you guys are all on here. Someone speak up. So my thing is x plus 1 minus 3. There we go. Okay. My vertex is -1, -3, not -3, -1. Okay? So careful. See? Everyone makes mistakes when you're being sloppy. All right. Try again. Here's my thing. I've got 10 equals the absolute value of 12 plus 1 minus 3. Okay. 10 equals the absolute value of 13 minus 3. The absolute value of 13 is 13. 10 equals 10. Yes, it does. So this guy is on the line. So this one is yes or true. Sorry, true. Okay. So that's it for your test tomorrow. It is a lot of factoring. It's heavy factoring. So make sure you guys are good with your factoring. Okay. And make sure you guys are good with your review. So let me just grab another sheet of paper here and write it all out for you. So we've got factoring tomorrow. For review, we've got absolute value. We have polynomials, where you're going to add, subtract, and multiply. We have, let's see, you've got, for factoring, you've got GCF, difference of squares. If I could spell, that'd be great. Difference of squares. Have trinomials. And then you have ones that are prime. Okay, and I think that's all. Should be pretty easy. Oh, with polynomials, you guys need to do degrees, leading coefficient, constant, standard form. Okay, so that's what's on your test tomorrow. If you want me to do any other type of problem, put it in the chat right now, and I'll do another type of problem. If not, you guys are good to go. I'll let your teachers know that you were here. I've already taken a picture of the chat so that I can let them know who is here and who is not. And thanks, Mr. David, for stopping by. You guys all good? All right, Angelica, go to Harvard, and I will see you guys. Well, I won't really see you, but you guys can come to my Zoom if you want and see me. Bye, guys. Have a good night.